Given the following function, f of x equals 2x squared plus 3 if x is greater than negative 1, or f of x will equal 4x minus 5 if x is less than or equal to negative 1. We need to find f of 3, f of negative 1, f of 0, and f of negative 6. Now, in order to be successful with an exercise like this, you need to first figure out which function you're using. Are you going to be using the top function or the bottom function? You can do that based upon which x value you have. So take, for example, this first one, f of 3. Normally we have f of x. So x was replaced with 3. That means our x value is 3. And that's going to help us determine which function we use based on these little inequalities over here on the right. So we need to just substitute 3 in there and see which inequality is true. So we have 3, is 3 greater than negative 1, or is 3 less than or equal to negative 1? And in this case, 3 is greater than negative 1, so we will use the function 2x squared plus 3 for this input. So, let me get my pen here. We will have 2 times our input squared plus 3. And the input here is, in fact, 3. So we can now start simplifying this down. We can say that 3 squared is 9. 9 times 2 is 18. 18 plus 3 gives you a final answer of 21. So we can use this same process for the next example, f of negative 1. I know that normally it's f of x, but now x was replaced with negative 1. So I want to write that down really quick. X is negative 1. So which inequality is true when we put negative 1 in for x? And this time it's going to be this bottom inequality. If x equals negative 1, negative 1 will be equal to negative 1. So we want to stick with this bottom one down here. So that means we will be using 4x minus 5 to solve this one. But again, we don't have x, we have negative 1 for our input. So that means we will leave it as negative 1. And 4 times negative 1 is negative 4. Negative 4 minus 5 more is negative 9. And like I mentioned already, we can use the same process for these other two here. So first we figure out, or we write down, hey, x is 0. We know that. That's something we know. Normally it's x here. It has been replaced with 0. So the question is 0 greater than negative 1, or is 0 less than or equal to negative 1? So in this case, 0 is greater than negative 1. So that means we will be using the top function again. So I will have 2 times the input squared plus 3. And again, normally there's an x here, but the input changed to 0, so I will be using 0 here. So 0 squared is 0, 0 times 2 is 0, 0 plus 3 is 3. And then finally with this last one, x is equal to negative 6. Negative 6 is less than negative 1. So we will be using this bottom function, which tells you that you will take 4 times your input and then subtract 5. The input here is negative 6. 4 times negative 6 is negative 24. Negative 24 minus 5 more is negative 29. Determine whether each function is even, odd, or neither. In the first example on the left side of the screen, you can see that the function is f of x equals 3x to the fourth minus 7x squared plus 11. And the first step to figuring out whether a function is even, odd, or neither is to substitute negative x in, or make your input negative x. So let me do this. So all of these x's will become negative x. And then we just have to remember that if you have negative x to an even power, that will leave you with a positive version of that x to an even power. And if you have negative x to an odd power, that will leave you with the negative x to the odd power. So now we can go back and find out what these three terms simplify to. So I see I have f of negative x will equal, since this is an even power here, negative x to the fourth power will be a positive x to the fourth power, because it seems like the negative goes away. So a positive x to the fourth times positive 3 will give you a positive 3x to the fourth power. In the second term here, this is negative 7 times negative x squared. Oh, this is an even number, so that means this is really going to be a positive x squared. So a positive x squared times a negative 7 will be a negative 7x squared. And then in the last term, there are no x's, right? We don't have to worry about raising x to any powers, so that just stays as 11. So then what we do is we go back to the original function and to the new function, and we compare sign changes. So we look, the first term is a positive 3x to the fourth, the first term is a positive 3x to the fourth. The second term is a negative 7x squared. The second term down here is a negative 7x squared. The third term here is positive 11. The third term here is positive 11. It looks like none of the signs changed. We had a positive, negative, positive. We had a positive to start with, negative, positive. No signs changed. This means we have an even function. So when you run through this example and no signs change, you are left with an even function. In the second example, over here on the right, you see g of x equals 6x to the fifth plus 4x cubed minus x. So again, the first thing you want to do is to find g of negative x. So I'm just going to change my input over here, plus 4 minus 2, negative x, negative x, negative x. And I'm also going to make sure that I do not miss the cube here, all right? So looking back over here, we just have to play this game here. These are all odd powers, so I guess we just need this one down here for right now. If you have negative x raised to an odd power, the x will stay, or that whole factor will stay negative x to the odd power. So what that means is that over here, we have negative x to the fifth power. That means it's going to be a negative x to the fifth power without the parentheses. So when you multiply 6 times negative x to the fifth power, you end up with equaling, let's see, negative 6x to the fifth power. So this is g of negative x. And the same thing happens here. When you have negative x to the third power, this is a negative times a positive will make it negative 4x to the third power. And I think it's the easiest to see back here. When you have negative x to the first power, we don't write it, but it's there. it becomes negative x, like if it weren't there. And what happens is the opposite of negative x becomes positive x. So then we compare the signs of each one. So this was a positive 6x to the fifth power. It became a negative 6x to the fifth power. This was a positive 4x cubed. This became a negative 4x cubed. This is a negative x. It changed to a positive x. So these signs, positive, positive, negative, turned into negative, negative, positive. So what that means is all signs changed. That means this function is odd. So when all of the signs change, that means the function is odd. So this is an odd function because all of the signs changed. On this next slide, you can see we have two more functions to look at. We'll start on the left. H of x equals 4x squared plus 3x minus 2. So again, you will replace the x with negative x. So there will be a negative x and another negative x. So this is h of negative x equals 4 times negative x squared plus 3 times negative x minus 2. So again, you just have to remember that this x negative x squared will be positive, so positive x squared times 4 is a positive 4x squared. A 3 times a negative x, rather a positive 3 times a negative x is negative 3x, and then negative 2 just stays the same. So this is h of negative x. So we take these two functions and we compare the signs. So the first sign here, 4x squared, stayed positive. The next sign here, let's see, so positive. The next sign went from positive to negative, and the last sign went from negative to negative. So this sign stayed the same, this sign changed, this sign stayed the same. Oh, we have a mixture of changing and staying. So let's say if some signs change, this function is neither. Right, that's the answer. It's neither, but neither what? It's neither odd nor even. So we just call it neither. And that happens when some signs change and some signs don't. All right, for this last one, again, k of x equals 5x squared plus 9. Again, we need to change the input to negative x. And when you do that, you'll see that k of negative x equals, well, the plus 9 doesn't change because we didn't substitute anything in over here. But negative x to the second power, that's even. So an even exponent means this is going to be positive x squared. So positive x squared times 5, positive 5 is positive 5x squared. So the signs here went from being positive to being positive and being positive to being positive. So these signs both stayed, which means no signs changed. And if no signs change, this is an even function. The area of a rectangular picture frame is 28 square inches. Find the dimensions of the picture frame if the length is 1 inch less than twice the width. So the first thing I like to do in a situation like this is draw a picture. So I know this is going to be a rectangle, as so. And I also know that the area of this rectangle is 28 square inches. And I wrote it inside the rectangle to again let myself know that this is an area. Now, how do we decode this last piece? The length is 1 less than twice the width. In order to decode that, you'd always want to start with the second dimension. So the first dimension that's listed is length, the second dimension that's listed is width. And that's what you want to be x. The second dimension, x will be the width. That way we can represent the first one, the length, in terms of the width. So I'm going to call this the width here, that's fine. So if this is the width, we know the length is, let's see, start with the multiplication, just like the order of operations. So 2 times twice the width. So twice the width. And then it's 1 inch less than that. So whatever else you're either going to be adding or subtracting, we've already taken care of the multiplication, twice the width. After that, in the order of operations, comes addition or subtraction. They're on the same level. But since this is less than that, we will be taking away 1. So the multiplication happens in front of the x, the addition or subtraction happens behind the x. So this side will also be 2x minus 1. Cool. So we have a width, we have a length, and we have an area. Lucky for you, you all remember that the area of a rectangle is length times width. So with the width being x, I'm just going to make that substitution. And with the length being 2x minus 1, I will also make that substitution. And that will equal the area, which we knew from right here, is 28 inches squared. All right, so we have an equation. Let's see, what should we do next? Well, I have this x just sort of floating around out here. Maybe we should distribute that through here and here, just to make sure. Maybe it'll make it look nicer. So we'll do 28 equals 2x squared minus x. Oh, well now it's pretty plain to see that this is a quadratic equation. And with the quadratic equation, it's generally a really good idea to get an equal 0 on one side. So in order to do that, I'm going to subtract 28 from both sides and get that 0 equals 2x squared minus x minus 28. Okay, so now what? Can we use factoring? Can we use quadratic formula? Can we use the square root property? Well, can't use the square root property because of this b term here, so that messes that up. I say we try factoring. So over here I'm going to create my little table, a, c, and b. So a times c, 2 times negative 28 is negative 56, and b here is negative 1. And again, we don't write it there, but it is there. So there we go. It is just negative 1. And that means my two numbers, I'll pause to give you guys a second to come up with them all by yourself. The two numbers here will be negative 8 and 7. So we can split this up into negative 8x plus 7x minus 28, and then the 2x squared comes along for the ride. So the minus 28 and the 2x squared are there. So then we can group these up together and common factor out a 2x. That leaves you with x minus 4. And when you group up these second two, it looks like you can common factor out a positive 7, leaving you with an x minus 4. And all of this is still equal to 0. And one thing to remember is that the sign of the third term will be the sign of the second common factor. It just comes along for the ride there. So I'm going to have to continue this over here. This tells you what now? We have x minus 4 and x minus 4 in common, so I'm going to write that first. So I have 0 equals x minus 4. Still in its own set of parentheses. And since we've already written those, that means we can get rid of this and this, which leaves us left with a 2x plus 7 in its own set of parentheses. So 2x plus 7. Finally, we can take each of these factors, set it equal to 0, and solve for x. So this would leave us with an x equals 4 and an x equals negative 7 over 2. Now with this particular answer here, it paired up with the fact that we are looking for distances, means that this cannot be our answer. In the real world, which is what this problem is dealing with in the real world, there's no such thing as a negative distance, so we have to toss out the negative answer, meaning we are left with x equals 4. Well, that's fine. That's our width. Our width is 4 inches. But it asks for the dimensions, plural. So we have to figure out what the length of this is. And it's easy enough. We can just substitute 4 into this x here to get 2 times 4 minus 1, which means that the length is 7 inches. There are your answers for this exercise.